and a warm welcome to everyone joining us today. I hope you're having a fantastic day so far. It's great to see so many of you here with us. I truly appreciate your time and interest in today's webinar on how DDI Solutions supercharge connectivity in modern seaports. And I'm happy to deliver an insightful session for you all. This webinar isn't just for seaport stakeholders and IT professionals. If you are individuals with interest on seaports and curious to know how the port terminal operations are implemented smoothly and how seaports network are secure and active 24/7 without compromises, you are in the right place and welcome to stay in with us till the end of the session. Seaports are one of the complex business environments with advanced technologies and equipment. From navigation, loading, unloading, route mapping, goods monitoring, and etc. Every port terminal operation requires network infrastructure capable of scalability, security, and efficiency. But managing and monitoring this complex network is challenging, especially with a large number of devices, remote logins, and increasing cyber threats. Here's where DDI solutions play a crucial role in streamlining network operations. By integrating DNS, DHCP, and IPAM, seaports can ensure real-time network automation, security, and scalability, all while delivering a seamless port terminal operations and goods transport. So let's get started. Let me introduce myself. I'm your host, Vikram Aditya, product expert from ManageEngine. I collaborate closely with the marketing teams for ManageEngine DDI Central and Cloud DNS. A big part of what I do is talk about the critical network services like DNS, DHCP, and IPAM, and how they play a vital role in driving operational efficiency and digital transformation. Today, I'm here to share insights on how DDI solutions can enhance the security and efficiency of seaports networks. Before we dive in, let's take a quick look at today's agenda. First, we'll start by identifying the key network issues faced by modern seaports and why they struggle to manage cybersecurity attacks and threats. Next, we'll discuss the important network demands of seaports environments for ensuring seamless IT and OT convergence. We'll then look at the network segmentation strategies and how important they are for optimizing and enforcing device restrictions on connectivity across different port locations. Port operations must be efficient, so we'll cover how real-time updates, monitoring, and connectivity mitigate delays and errors. The security of the port operations is very critical, and we'll explore how low latency connectivity enhances surveillance, IoT integration, and overall safety. Availability of network services must be persistent, so we will discuss how automated failover mechanisms sustain core services to run 24/7. And the cybersecurity is the topmost priority. And we will talk about how DNS firewall policies and network segmentation help mitigate cyber threats and unauthorized access. Finally, we'll discuss how a robust IP infrastructure supports the longevity of seaports network support and efficiency of ports operations through real-life use cases. By the end of the session, you'll have a clear understanding of how modern seaports stay connected, secure, and strong with the power of DDI solutions. Cyber attacks in seaports environments can lead to disruptions in port services, resulting in loss of tracking ships and ports, delay in goods transportation, port operations getting halted, revenue and data loss, and more. To prove and understand these more, let us look at some of the real-life incidents and visual representations of how cyber attacks impact the functionality of modern seaports. First case is a ransomware attack on the maritime software which impacts over 100,000 ships. This happened on January 7, 2023, where Oslo-based DNV, one of the world's largest maritime organizations, was hit by a ransomware attack, which led to them to shut down all of their IT servers connected to their ship manager system. This affected around 100 vessels and 70 customers to which DNV were communicating daily to update them on the ongoing investigation. And the second case was another ransomware attack on the port of Lisbon, Portugal. This happened on December 25th, 2022, which was Christmas, and the port of Lisbon in Portugal was targeted by the Lockbit 3.0 ransomware group. The attackers claimed to have stolen sensitive data, including their financial reports and customer information, and demanded a ransom of 1.5 million US dollars. The port's website was taken offline, and the attackers threatened to publish the stolen data if the ransom was not paid by January 18, 2023. Graph you see is from the Maritime Cyber Attack Database (MCAD). They have documented over 160 discrete cyber attacks on the maritime transportation sector. They have revealed that the trends of cyber attacks is increasing steadily from 2014 to 2023. According to this data, these cyber attacks targeted a wide range of systems in the maritime industry, systems including navigation, port infrastructure, shipping companies, maritime authorities, government agencies, shipbuilders, and defense contractors. This data will be a caution to the seaport sector that increasing cyber attacks would risk their network infrastructure to get exposed to unauthorized individuals. And so they need to implement strategies and solutions to strengthen their network security before attackers breach in and steal their data. Now, the major reason considered for the increase is the digital transformation. Modern seaports are implementing various new technologies and equipment to their network to enhance their port operations efficiency, thus expanding their network and making it complex for admins to monitor and manage. Next graph you see on screen is a comprehensive review conducted on the overall reported cyber attack incidents from 2011 to 2024, where a total of 68 incidents were identified, and they were arranged in the graph based on the frequency of attacks occurred in the past decade with their types. DDoS attack appeared in 2012, 2016, and 2020 at a random level, but their frequency was low. However, we can see an increase in DDoS attack in 2023 in the Maritime Supply Chain Network (MSCN), indicating that DDoS has become a major cyber threat in the following years. We also see that hijacking, jamming, and spoofing have been significantly increased, along with ransomware, malware, and trojans, thus being a persistent threat in the MSCN. Let's take a closer look at the image on screen. Modern seaports are vast, interconnected ecosystems where every port operation relies on a seamless and secure network connectivity, whether IT or operational technology driven. From international terminals to domestic operations, data centers, and remote employees, a reliable and scalable network backbone is very crucial to ensure smooth and uninterrupted operations. This is where a private WAN backbone comes into play, enabling seaports to securely connect, segment, and manage critical port operations under a unified infrastructure. Now, the main challenge here is to unify all these systems connected to seaports, private WAN backbone connected via technologies like IP/MPLS via VPN, SD-WANs or SDNs under a cohesive IP address plan driven by an intelligent automation. This ensures seamless interconnection, high availability, and efficient traffic management, laying the foundation for future growth and enabling seaports to supply real-time operations effortlessly. By addressing these challenges with modern DDI solutions, seaports operators can create programmable, scalable IP networks that drive efficiency, resilience, and innovation across multiple seaports. Let's now discuss the key demands of the modern distributed seaport network for better growth. When evolving into a highly connected ecosystem, they face several challenges that can impact port efficiency and security. Network admins of Seaports would definitely require a clear visibility over the core network services for seamless management and monitoring, and also helping in troubleshooting network issues, delays, and threats. So, without its centralized view, managing multiple devices and IP resources in the network would be complex and hazardous. Expanding the network means that the number of devices connected would increase, and the services like IP allocation, domain translation, device verifying, configurations, and etc. can't be done manually by admins for every individual task. This results in the need for an automating tasks based on policies to reduce manual work and error while increasing network efficiency. Network solution that provides facilities to configure network services to ensure only trusted clients of the seaports are entering the network without any interruptions, preventing unauthorized individuals from gaining access, which is considered a must for the seaports network environment to work securely and effectively. And as said before, implementing new technologies and equipment means network infrastructure becomes more complex to manage, making it vulnerable to cyber threats and risks. So, organizations like Seaports need a solution that provides robust security to their network infrastructure. Finally, seaports require to merge information technology with their operation technology under a unified IP infrastructure for a complete digital transformation. So they need a solution that merges both technologies without integration challenges. Let's explore how a DDI solution builds the foundation for such mission critical IP communications within seaports networks. First, what is DDI? A DDI is a specialized network management solution that provides a unified management console for the three core network services DNS, DHCP, and IPAM. It enables you to take complete control over your DNS and DHCP clusters and gain holistic as well as deeper visibility into the configurations of these three services. DDI solution, you can easily define and manage scopes, dynamically lease IP headers to hosts, set up custom DHCP device fingerprinting policies, manage DNS zones, zone scopes and records, set up DNS security policies, analyze DNS query traffic, review audit logs, manage dual stack IP address inventories of your network, all through a single window. ManageEngine has its own DDI solution called ManageEngine DDI Central. It is a user-friendly, specialized solution that unifies DNS, DHCP, and IPAM into a single platform for improving operation efficiency and network stability. It manages your existing Linux-based ISC by 9 and ISC DHCP installations and can also set up new clusters. It can also manage your Microsoft Windows DNS and DHCP clusters. Throughout this webinar, you will see its tools and features being highlighted to witness a DDI solution in action. What if I told you that this one window solution can also serve as a single point of management for all the interconnected port center networks of any modern distributed seaport? Yes, with the DDI solution, you can easily manage the DNS, DHCP, and IPAM configurations of each data port site, which is already connected to the organization's network using advanced technologies like SD-WAN, IP-MPLS core via VPN, or even dark fiber cables. As we onboard all your DNS and DHCP servers of a seaport as a cluster into DDI Central, it starts discovering all the configurations on a granular level to consolidate and correlate the configurations, facilitating a contextualized visibility. With all the configurations organized in its UI, you can easily control your core network services and make required amendments to them. Analyze the rich visual analytics that accompany each module to get quick visual snapshots to arrive at valuable and actionable insights that quicken troubleshoot. This way, Seaports network admins can holistically view and centrally manage the core network services of distributed ports facilitating which spread across the globe all from a single window. DDI Central's centralized platform offers an efficient solution for managing networks across seaports by treating each on-premise facility as a separate cluster with its own internalized IPAM. The platform allows for seamless integration of DNS and DHCP servers for each port locations and data centers, added individually to their respective clusters. With a unified interface, users can easily discover, configure, and manage network settings across all locations. Additionally, the platform provides robust monitoring tools to ensure the health and performance of critical core services, offering a comprehensive and streamlined approach to the network management across the seaport. Let's see how this is possible with ManageEngine's own DDI solution, DDI Central. Here, you can manage your each seaport subsystem as a separate cluster based on their operating system, Linux or Windows. Each cluster comes with its internalized IPAM, DNS manager, DHCP manager, and can be managed independently of other clusters. All you have to do is add and manage the DNS and DHCP servers of each port to each cluster and discover their configurations and manage them from a unified window. You can just choose the cluster of your choice and monitor the health and performance of its core services in real time. So, this is how you can seamlessly scale as your distributed seaport facilitates growth during port facility using DDI Central. Based access controls is one of the core benefiting features in DDI Central when it comes to access granting and configuring. This enables network admins to grant permissions to individuals of the organization based on their roles. In RBAC, we got four roles, two primary administrator and operator roles, and the other two roles are only for monitoring purpose. The admin role provides access to all the clusters and settings, while the operator role provides specific access based on their individual's responsibilities. Permissions can be limited on cluster based, service specific, and zone level for every individual based on their hierarchical role. By providing this flexibility in permissions assignment, DDI Central ensures that operators have just the right level of access to perform their tasks effectively, while maintaining security and minimizing the risk of unauthorized changes. Let's now look at the port layout. Seaports and ships contain variety of devices, each having their own purpose for a smooth port operation, such as automated guided vehicles, ECDAS, radios, IoT sensors, port operators, drones, pipelines, and etc. All these devices need to be compartmentalized for segmenting the network between devices to prevent issues like IP conflicts, network delays, and connectivity troubles. Seaport network admins are required to mirror this setup under a cohesive IP address plan. This means each area of the seaport requires a dedicated subnet or VLAN to ensure optimized connectivities and security. Imagine how many administrators you require to manually manage such an integrated network structure. It is highly impractical. Here's where a DDI solution becomes essential. Its automated IP provisioning ensures every device gets the right address dynamically. Centralized management allows network admins to monitor and adjust configurations in real time. It helps enforce security policies dynamically, reducing risk and ensuring zero network overlap between ship and port devices. See how DDI Central simplifies defining and managing these scopes. Seaports network will have multiple devices and machines to be operated and moderated manually or automation. For that, IP leasing is important. In order to prevent network overlapping and IP conflict, multiple devices in the network will be segmented into different individual sections, and this process is called network segmentation. The segmentation can be easily done with what's called DHCP Scope Manager in DDI Central, where admins can segment, organize in hierarchy, and combine into one large network. Let's see how segmentation is done in DDI Central. You can create subnets with a specific pool range for specific devices and machines in your seaport, like radios, sensors, cameras, routers, operators, screens, etc. Which helps in segmenting different departments without overlapping. You can also create static subnets of different pool ranges to ensure leasing is done for specific defined devices and prevent DHCP from leasing for general uses. This is a way of separating from other subnets and providing a specific purpose for leasing. You can add different subnets with different pool into a single supernet for administrators to organize multiple subnets in hierarchy for an easy visual breakdown. Admins can combine multiple different subnets and define configurations with DHCP options or custom options with the help of shared network. You can categorize certain subnets to be under a virtual LAN with VLAN and describe their purpose. You can assign fixed IPs for critical devices with the help of DHCP's host reservation. And it's important to note that SuperNet and VLAN helps in organizing subnets to make administration simplified, and there won't be any configurations available for both of them. As you can see in this image, the modern Seaports Internet of Things consist of both static and dynamic devices in the network. Static devices can stay connected in the network permanently, while dynamic devices need continuous IP allocation. The drones and IoT sensors are considered to be the eyes and ears of seaports, as they monitor and report all the port terminal operations and activities. So, their important functionality requires them to be connected immediately after entering the network. Here, network admins can either assign a fixed IP for that particular IoT sensor or drone through static subnet, or they can configure to allocate a fixed IP address automatically when the device joins and sends DHCP request through host reservation. Now, here's the catch. For static subnet, the admins have to do the manual work of assigning IP addresses to every device requesting to connect, also verifying whether they are legitimate devices. But in host reservation, admins can configure it to be the server's responsibility to automatically allocate an IP address to that specific device joining the network. And also, drones face denial of service attack mostly, where attackers interfere the network and take control over the drones, leading to data loss and misleading information. So network admins can utilize VLANs. VLANs are defined and VLAN-aware DHCP policies are implemented to seamlessly integrate IoT devices while isolating their broadcast traffic from the rest of the network, protecting them from cyber threats. DHCP reservations further enhance this setup by ensuring that critical surveillance devices always receive consistent IP address without the administrative overhead of static assignments. Finally, if you have two different devices in the separate subnets, but also have similar configurations needed to be implemented, you can add both subnets into a shared network and apply common policy to both. You can also add two different devices having the same configurations in the same subnet. The configured subnets are viewed under the IPAM module in DDI Central. The entire IP address inventory within that particular subnet is listed. As we delve deeper into a specific subnet in IPAM, a donut plot provides a visual breakdown of the number of IP addresses in the subnet according to their availability status. These visual snapshots assist admins with effective capacity planning and alert them at utilization thresholds. In the event of an IP conflict within a particular subnet, The admin can click on any available or free IP and directly assign it as a fixed address to one of the conflicting hosts until subsequent remediation. This way, admins can have hands-on control over the IP address inventory within a subnet. Ports are dynamic, high-security environments where different user groups, ship traffic controllers, port operators, ground traffic, external stakeholders need access to different sets of data. But how do we ensure that the right people get the right information without compromising security or efficiency? This is where DNS domain views play a crucial role in service segmentation. Let's break it down. Here, a client requests access to vesseldata.silkerseaport.com. If the client request comes from an authorized vessel traffic service VTS network, and if the client IP is found in the internal view match list, the DNS resolves the query to 10.20.1.10, which is a secure version used exclusively by vessel traffic service controllers for real-time ship and port data and situational awareness. This ensures that critical operational data remains protected with no risk of exposure to unauthorized access. But if the request originates from an external network, such as a vendor, a merchant, or an external stakeholder requesting to access vesseldata.zilkerseaport.com, the DNS resolves the domain to 198.51.100.20. This is an external version of the domain which does not possess any confidential data. This setup enables seaports to monitor ship and port statuses without accessing sensitive port data, ensuring that sensitive vessel traffic service data remains accessible only to authorized personnel while providing stakeholders and other individuals with the relevant data they need. This helps seaports enforce data access policies in alignment with the International Ship and Port Facility Security ISPS code. You can analyze the queries to the views configured along with the hosted and non-hosted domains. Alongside, you can have a visual breakdown over the number of queries to the views and domains for a custom time interval and the number of queries received per IP with the help of domain query analytics. Evaluate a domain thoroughly or a view's performance. Select a specific domain or view from the list. This will display the domain-specific performance metrics, including hourly query load over a user-defined timeframe. You will also see the details for IP addresses leased under this domain, such as lease duration, MAC addresses identifying each host, and the vendors of the host machines. Additionally, the total query load over across all IPs as well as the individual query loads are visually represented in a donut chart accessible by selecting the respective IP. Furthermore, a specific donut chart provides a visual breakdown of the query volume for different types of DNS records. Clicking on a record type, such as A or Quad A, will display a comprehensive list of all the zones queried for that specific record type. This list includes the key performance indicators such as hourly query load, queries per second, and the total number of queries covering the zones associated with the selected record type. Additionally, you can select a specific zone within the record type to drill down and view a visual summary of the query analytics about that zone's records. DDI solutions offer comprehensive built-in logging and reporting capabilities that aid in compliance with regulations like GDPR, ISPS code, International Convention for the Safety of Life at Sea, SOLAS, and more. DDI Central captures audit trails of every action executed on each and every object managed by the DNS and DHCP servers. You can choose the relevant subnets or zones and reports the audits of only those segments to the regulators. This saves time and reduces cost compared to reporting full network audits. Let us see how DDI Central implements auto failover setups for DNS and DHCP services. In DDI Central for DHCP service, while configuring a subnet, you can add one primary and add as many secondary servers. In case the primary server fails, the secondary server comes into the fore and handles the traffic. If you want these servers to split the load, you can enter the relevant value in the split field. A value of 128 here indicates a 50-50 load balancing actively involving both primary and secondary servers to handle the DHCP traffic. For the DNS servers, while configuring a domain, you can add multiple primary DNS servers for the domain. Subsequently, DDI Central also accepts a list of multiple secondary servers to facilitate reliable access to resources across a Seaport network. With the DDI solution in place, data from all three core network services are not only collected but also correlated and analyzed in one central hub. In a DDI solution like DDI Central, IPAM serves as the centralized and contextualized network source of truth that maps upstream relationships among the core services. As you can see in the image, behind the lease history of a particular IP, you get to see how it has been captured and correlated rich IP metadata like DNS records, DHCP lease information, and IP address allocations of various hosts within the network. This unified approach allows for a holistic view of network operators, enabling network admins to make timely and informed decisions based on comprehensive data analysis. This information aids in quickly troubleshooting network issues, optimizing resource, and maintaining stability. These three core services in sync with each other, DDI serves as a sophisticated automation hub, as it becomes easy to set up end-to-end automation involving these services. So here are some of the key processes that can be automated using a DDI solution. Using DHCP server, you can automatically assign IP address to host on the network. This enhances the efficiency of network resource management and ensures that IP addresses are reclaimed and reused appropriately, reducing IP address exhaustion. DNS is essential for mapping domain names to IP address across the network. The dynamic DNS feature automatically updates DNS records when IP addresses change, ensuring network resources remain accessible via their host names. A DDI solution streamlines this process by automating DNS updates whenever new servers, subnets, or applications are added. This eliminates the need for manual intervention, ensuring smooth connectivity. Such automation is critical in port networks where frequent device mobility and configuration changes require real-time updates. DA systems automatically detect and resolve IP conflicts and maintain an updated IP address inventory, ensuring reliable connectivity and preventing downtime in port terminal operations. Scheduled creation of DHCP scopes and DNS records allow network admins to go on a schedule it and forget it mode, enabling them to plan and implement network expansions or updates at predetermined times, which helps in maintaining uninterrupted service during operation hours. Scheduled DNS or DHCP report from time to time gives admins a real-time snapshots of subnet capacities and zone query analytics for strategic planning. DNS is the first point of contact across external networks. The DNS firewall constitutes the network's first line of defense. Following a layered approach, it imparts self-defending capabilities to ensure by the networks by placing strategic defenses against unwanted intrusions. It actively blocks malicious activity using domain blocking and mitigates ongoing attacks with its response rate limiting policies, also known as RRL. So let's see how DNS firewall works. Let's consider a scenario where a seaport operator has clicked a link with a crafty phishing email and unknowingly gets his or her system infected by the malware. Upon connecting to your port's private network, the malware tries to covertly access malicious sites using your DNS resolver. DDI Central easily manages such situations with its DNS firewall. This firewall maintains a blacklist comprising a recognized collection of undesirable domains. Before the resolver can provide the actual IP, it checks the domain against this list. If there is a match, the resolver does not proceed to fetch the real IP from the external authoritative DNS server. Instead of connecting to the malicious site, the user will get redirected to a safety page. Using DDI Central, you can configure the DNS sync settings for all the DNS clients in your cluster at global or universal level. By clicking on the DNS firewall in config section, you can provide the domain name to be blocked, category for blocking, and also the redirection IP to redirect clients to safer page. You can also view the domains blocked and domains blocked among the subdomains here. You can also view the blacklist of malicious domains in the view list section, and this data can also be imported as a CSV format. DDI Central's query analytics provide network admins insights on who sends the query on blocked domains and how many times the queries were sent. In the big tabular column, you can see details about the query request on malicious domains with record type, IP address, host details, and date and time. You can identify the host machine from which queries were sent through their name or their device's MAC address. Moreover, in the small tabular column, you can see how many queries were sent for that particular block domain IP, alongside a chart view on total queries per IP. Let's now dissect a common cyber attack scenario involving a botnet and discuss the defensive strategies that can be employed using a DDI solution. At core, we have the botnet command center targeting a particular victim network in your seaport. It keeps sending instructions to compromised endpoints called botnets. These botnets then execute the attack by sending malicious queries to the DNS servers using the IP address of the victim. This is known as IP spoofing. The DNS servers in your seaport network, unaware of the deception, responds to these queries. However, due to the nature of the attack, these responses are not just simple replies, they are massively amplified, meaning a small query triggers a large response. The final target of this onslaught is the victim network in your seaport facility. The amplified responses flood the victim's network, potentially overwhelming it with data and causing significant disruption. And this type of attack is known as the distributed denial of service or DDoS attack. These threats can be instantly identified using DDI Central's query analytics tool that visually charts unusual spikes in hourly traffic, indicating a DDoS attack in progress. To mitigate the DDoS attacks, DNS servers can be configured to limit the response rate to any individual IP address. This way, it prevents the DNS servers from being used as amplifiers in DDoS attacks and further prevent the movement of malware from compromised end user systems to more sensitive systems and data center resources. The response rate limiting RRL is a DNS security feature that intelligently regulates response throttling to mitigate the impact of DNS amplification attacks, ensuring uninterrupted access from legitimate clients and upholding a well-balanced approach to security. Let's see how response rate limiting, which is crucial for controlling DNS responses during amplification attacks, is implemented in DDI Central. This feature allows admins to set various parameters that control different aspects of DNS response behavior. The DDI Central's RRL does not just limit the number of identical responses per second from a single IP or subnet, but also limits the number of variety of DNS responses, such as error responses, DNS referral responses, specific types of DNS responses per second. You can also define how broadly rate limiting is applied across IP address ranges. It also enables you to specify the trusted clients that are exempt from rate limiting. Response rate limiting can be accessed in IIC bind by selecting rate limit in DNS options, which provides several fields to fill in details like all per second, error per second, prefix length for IPv4 and v6, and more. You can also provide the IP of your clients you want to exit from this list in the XM clients field. By selecting DNS RRL in configuration section, you can able to modify the DNS RRL settings by editing the values of your needs. You can also provide the IP of clients you want to exit from this list in the XM's client list section. By segmenting a network into subnets or scopes, you isolate each segment from the rest of the network. Each segment establishes an isolated broadcast domain with the DHCP server. Network segmentation is only a part of DDI Solution's layered security philosophy, enabling network to survive intrusions and minimize or even prevent successful data breaches. In the end, this allows for a speedy return to business as usual. Segmenting the scopes into subnets and VLANs helps contain the damage by isolating the affected segment, allowing admins to more effectively control the spread and mitigate risks. Subnetting also reduces network-wide threats by quarantining compromised areas and hindering unauthorized lateral movement within the network. So let us look at a use case. Seaports network contain confidential data of the goods, cargo, containers, and stakeholders, which need to be secured from the external network environment to prevent exposure. But on the other hand, they also need to facilitate work from home jobs from its port, yard, and gate operators during critical scenarios, and also to increase the operator's safety and prevent any accidents. This means that the network needs to securely identify and connect only the port operators to enter the network and access the data while preventing unauthorized individuals from gaining access. By that, operators can control cranes, drones, and other equipment from a remote location. DDI Central can help Seaports network with DHCP policies, where network admins can set up policies and configure them in DHCP servers to identify the operator's devices through their MAC address and permit only their device to enter the network. The operators will get classified in a separate client class where they will be allocated the required IP to join the network and control the equipment. This way, client class restricts the external unauthorized users who are trying to breach in the network through the public IP, thus increasing the network security. You can see in the configurations, this client class called port 52 is mapped to the particular subnet 100.100.100.0, and the MAC address of the operators have been listed along with the DHCP options, DNS domain name, DNS updates, and DNS update style. It has also been configured with match string as hardware, offset as 1, and length as 17. When the operator's device sends DHCP packets to the DHCP server, the client class finds the MAC address of hardware by following the match string and reads from the first character as offset is 1 and reads till the string character is 17. And finally, when the MAC address of the device matches the criteria in the list, the devices will be allocated with an IP address from the given subnet. We wrap up, let's reflect on what makes a seaport unique. Every port terminal operations are defined by its ships, destinations, and the millions of goods it transports at every travel. But behind this ever-changing environment is one constant: the need for a seamless, secure, and resilient network. from port operations and vessel traffic control to ship navigations and goods loading and unloading. Every function depends on a robust and relentless network. This is where DDI solutions make a significant difference. By managing IP address efficiently, automating DNS and DHCP operations, and providing real-time network visibility. Regardless of how complex or high traffic the seaport is, a full-stack DDI management platform enables smooth, outage-free, and scalable IT operations. By converging all seaports subnets, whether IT or OT, into a structured, policy-driven IP address plan, seaports can achieve seamless communication across yard, gate, and port operations. This cohesive approach empowers seaports IT teams to efficiently manage their distributed infrastructure within a unified agile network. A well-architectured DDI solution keeps everything running, optimizing performance, securing mission-critical operations, and ensuring future growth. And yes, behind every busy harbor is a network that never slows down. Thank you for taking your time to be a part of this webinar. Right after this session, you will be directed to our downloads page where you can start your 30-day free trial today. You can also visit our demo page where we have a live interactive demo up and running for you to explore and play around with. If you have any queries, please shoot us an email at ddaisupport@manageengine.com. This is your host Vikram Aditya signing off. Thank you so much.